Here we have another an example of telescopic series. The general term an is e1 by n minus e1 by n plus 1. Okay, we need to find the sum to infinity, but what if we find sum to n? That would be I from 1 to n e1 by I minus e1 by I plus 1. So basically, I changed the counter. If you notice, this is I, just that you don't confuse. N is the end point. Okay. So when I put 1 in there, it will be like E1 minus E1 by 2 summation. So therefore, I have to add. When I put 2 in there, this will be 1 by 2 minus E1 by 3. When I put 3 in there, this would be E1 by 3 minus E1 by 4. If you keep on going like this, nth term is e1 by n minus e1 by n plus 1. And you can also actually try to write the previous term by putting n minus 1, e1 by n minus 1 minus e1 by n. Okay. You guys notice here that I have this e to the power half, e to the power half in the opposite signs. This will cancel. Similarly, I've not written it, but I know the next term will cancel this and so on, right? Each of the first term is being cancelled, right? So what I've left with, the first and the last term here. That means Sn basically is e to the power 1 minus e to the power 1 by n. We want to find S infinity. This is Sn. So S infinity would be limit n approaches to infinity of Sn. Basically, limit n approaches to infinity of e to the power 1 minus e to the power 1 by n. That would be e to the power 1 is constant. And what do you guys notice? Where would 1 by n approach to? As n approaches to infinity, 1 by n approach to 0. So we can write this as e to the power 0. Anything power 0 is 1. So the answer to your sum of the series should be e minus 1. Let's work on another example. This is a natural log kind of a series. Natural log of n by n plus 1. N is from 1 to infinity. Again, we need to find the sum to infinity. I can use the property of the logs to write this as log of n minus log of n plus 1, if you guys notice. So my general term basically is log of n minus log of n plus 1. If I try to write Sn will be the sum of first n terms. Log of I minus log of I plus 1. When I put 1 in there, it will be like log of 1. Let's write it here actually. When I put 1 in there, that would be log of 1 minus log of 2 plus log of 2 minus log of 3 plus log of 3 minus log of 4 and so on. The last term would be log of n minus log of n plus 1. What about the previous term? Log of n minus 1 plus log of n. Okay. Now we notice this log 2 and log 2 cancels. So that is the fun of telescoping series, that a lot of terms get cancelled, right? So what we can write is that Sn would be natural log of 1, that's the first term, and the last term will be left also because all the other terms will be cancelled. Now we can notice here that log of 1 is anyways 0, always 0. So we only are actually having a negative natural log of n plus 1. We want to find S infinity. So S infinity is limit n approaches to infinity of Sn. What is that? Limit n approaches to infinity of negative log of n plus 1. Do you guys remember what is x approaches to infinity of log of x? That was infinity, because you guys remember the graph of log x goes like this. As x approaches to infinity, log x approaches to infinity. So this basically is gonna come to negative infinity. If the sum S infinity of any series is coming to be anything infinity, we say the given series diverges. We do not say this converges to infinity, we say that is diverges. Here we have another example. an here, the general term is 1 by root n minus 1 by n plus 1. Okay. We need to find the sum up to infinity for this. What's nth sum? Nth sum meaning we have to go up to n. Because we have to go up to n, we just change the index, we don't get confused. Minus 1 by I plus 1 square root. Let's expand this. This is from 4. Sorry, notice this is from 4. When I put 4 in there, this will be square root of 4 minus square root of 5. When I put 5 in there, square root of 5 minus square root of 6. When I put 6 in there, 1 by root 6 minus 1 by root 7, and go on. The last term is 1 by root n minus 1 by root n plus 1. What will be before that? Let's try to write one term before that just to observe the pattern. Square root of n minus 1 minus square root of n. Let's see. We have this 1 by root 5 and 1 by root 5 cancel because they're opposite sign. This is going to cancel. Similarly, if I didn't write all the terms, but this will also cancel. And this will cancel as this is also cancelling. So what we have is the Sn is 1 by root 4, which is, let's write 1 by 4 for it now. And the last term will be left, n plus 1. That's basically 1 by 2 minus this. We need to find S infinity again. S infinity is limit n approaches to infinity of Sn. Limit n approaches to infinity of 1 by 2 minus, as n is approaching to infinity, this n plus 1 will approach to infinity, square root of n plus 1 will approach to infinity, this will approach to 0. So we have the answer 2 by 1 by 2. The given series converge to 1 by 2.